Night falls slowly over Hawaii, and the ocean turns to ink. Along the island's southern edge, waves collapse against cliffs of hardened basalt, black stone born from ancient fire. The wind carries the scent of salt and sulfur. In the distance, a faint crimson glow pulses against the clouds, as if the earth itself were keeping time with a hidden heartbeat. This is Kilauea. From above, it does not always appear fierce. Its slopes stretch gently toward the sea, cloaked in rainforest and mist. But beneath that quiet surface, magma moves, slow, luminous, unstoppable. Rivers of molten rock wind through fractures in the earth, carving paths through forests, spilling across plains, and sometimes reaching the ocean in bursts of steam and thunder. When lava meets water, the world hisses. White plumes rise skyward, swirling like spirits between land and sea. New coastline forms in moments, glowing rock cooling into black glass. What was once open ocean becomes solid ground. Creation happens in real time. At the summit, within a vast caldera, Halemaʻumaʻu crater flickers with inner light. The lava lake churns like a living eye, reflecting stars at night and sending embers of orange into the darkness. The ground trembles softly. Cracks widen. Steam escapes from hidden vents with quiet sighs. Here, time feels different. Land is not fixed, it flows. Forests are erased and reborn. Cliffs collapse. Shorelines advance. The island is young, and it knows it. For centuries, people have stood at this threshold between fire and sea, watching the red glow breathe against the sky. Some see geology, others see divinity. All feel the same awe. The recognition that beneath our fragile human world lies a force vast and patient. Kilauea is not merely a volcano. It is the living pulse of the Pacific, a reminder that the planet is still forming, still shifting, still alive. And as long as magma rises from the deep, the story of this island will never truly end. Kilauea rises from the southeastern flank of Hawaii Island, the largest and youngest island in the Hawaiian chain. Though often overshadowed by the immense bulk of Mauna Loa to the west, Kilauea is among the most active volcanoes on Earth, restless, prolific, and constantly reshaping the landscape around it. Unlike steep, explosive stratovolcanoes, Kilauea is a shield volcano. Its broad, gently sloping profile was built over hundreds of thousands of years by repeated flows of low-viscosity basaltic lava. This lava, fluid and fast-moving compared to thicker magmas elsewhere, spreads outward in thin layers. Each eruption adds another sheet of rock, gradually building the volcano outward rather than upward. The result is a structure that appears almost subtle at first glance, a vast shield of dark stone stretching toward the sea. At its summit lies a large caldera, formed when underground magma chambers partially emptied and the surface above collapsed. Within this depression sits Halemaʻumaʻu crater, a smaller but dramatic pit that has, at various times, contained a glowing lava lake. The crater floor rises and falls depending on magma supply, creating cycles of inflation and deflation that subtly reshape the summit. Two major rift zones extend from Kilauea like cracks in a fractured shield: the East Rift Zone and the Southwest Rift Zone. These are elongated regions of weakness where magma travels laterally away from the summit. Instead of erupting only at the top, lava can emerge miles away through fissures that suddenly split open the earth. Entire neighborhoods have, at times, found themselves atop newly active vents. The island itself is geologically young, less than 1 million years old, and still growing. When lava flows reach the Pacific Ocean, they cool rapidly, forming new coastal land. Black sand beaches and jagged lava deltas are born from this fiery meeting of elements. Over time, these raw surfaces weather and soften, eventually supporting vegetation. Beneath the visible landscape lies a complex volcanic plumbing system. interconnected magma chambers, conduits, and dikes that transport molten rock from deep within the mantle. The ground above subtly rises as magma accumulates, then sinks when it drains away. Instruments measure these movements in centimeters, yet they reflect colossal forces operating miles below. Kilauea's geological story is inseparable from the broader formation of the Hawaiian Islands themselves. It represents a moment in an ongoing chain of creation, a stage in the Pacific Plate's journey over a deep mantle plume. Standing on its slopes, one stands on rock that was once liquid fire. Every hardened flow is a record of eruption. Every cliff face reveals layered histories of molten rivers turned to stone. Kilauea is not a relic of some distant prehistoric past. It is geology unfolding in the present tense, a volcano still writing the map of the island, one eruption at a time. Far beneath the floor of the Pacific Ocean, deeper than any human has ever traveled, a column of heat rises slowly through Earth's mantle. It does not drift with the shifting crust above. It does not wander. It endures. This is the Hawaiian Hotspot, a plume of abnormally hot mantle material that has burned its mark across the Pacific for millions of years. Unlike most volcanoes on Earth, which form along the boundaries of tectonic plates where they collide or pull apart, Kilauea exists in the middle of a plate. The Pacific Plate moves steadily northwest, inching along at roughly a few centimeters per year. Beneath it, the hotspot remains relatively stationary. As the plate glides across this source of heat, new volcanoes rise directly above it, while older ones drift away, cool, erode, and eventually sink beneath the sea. The visible result is the long chain of the Hawaiian Islands, stretching across thousands of kilometers of ocean. At the southeastern end of this chain lies Hawaii Island, the youngest and most volcanically active of them all. And on its flank, Kilauea continues the work of creation. Kilauea's eruptions are typically effusive rather than explosive. The magma rising from the hotspot is basaltic, low in silica and relatively fluid. This allows gases to escape more easily, reducing the violent pressure buildup seen in more explosive volcanoes. Instead of catastrophic blasts, Kilauea often produces lava fountains, glowing rivers of molten rock, and sustained lava lakes that churn for months or years. Yet gentle is a relative term. When fissures open along the East Rift Zone, lava can surge upward in fiery curtains, spraying molten fragments into the night sky. In 1959, lava fountains soared hundreds of meters above Kilauea Iki crater. Beginning in 1983, a long-lived eruption along the rift zone sent lava flows steadily toward the ocean for decades, reshaping entire coastlines. In 2018, the volcano demonstrated its power again, as a series of fissures tore through residential districts, releasing lava fountains and vast quantities of volcanic gas. The summit caldera partially collapsed as magma drained away, lowering the crater floor dramatically. Kilauea behaves almost like a living organism. It inflates as magma accumulates beneath the surface, swelling subtly upward. It deflates as eruptions release that pressure. Seismic tremors ripple through the ground before lava emerges. Instruments detect these signals: earthquakes, gas emissions, ground deformation, offering glimpses into the hidden mechanics below. But even with advanced monitoring, the volcano resists full predictability. Magma may change course underground. Fissures may open unexpectedly. Lava tubes can carry molten rock miles from its source before it emerges in a new location. The Hawaiian hotspot continues to feed Kilauea, and in time, it will create new volcanoes even farther southeast beneath the ocean's surface. The island we see today is only one moment in a moving geological story. Here, tectonic motion and deep mantle heat combine to form one of the most extraordinary volcanic systems on Earth, a place where the planet's interior meets the open sky and where new land is forged in fire. The slopes of Kilauea exist within a tapestry of shifting climates, shaped by trade winds, elevation, and the presence of the vast Pacific Ocean. Moist air flows in from the northeast, carried by steady trade winds. As this air rises along the windward side of Hawaii Island, it cools and condenses into frequent rainfall. Here, dense rainforests flourish, thick with ohi-a-lehua trees, towering ferns, and moss-covered lava rock. Waterfalls cascade through green ravines carved into ancient flows. Mist lingers in the canopy. But cross the volcano to the leeward side, and the landscape shifts dramatically. Rain shadows create drier conditions. Vegetation thins into shrubland and hardy grasses. Black lava fields stretch beneath open sky, absorbing the sun's heat. In some areas, cracked basalt dominates the view, vast frozen waves of stone where little soil has yet formed. Elevation adds further contrast. Higher slopes experience cooler temperatures and heavier rainfall, while lower coastal areas remain warm year-round. The interplay of altitude and wind creates microclimates within short distances, lush forest giving way to barren lava plains in a matter of kilometers. Volcanic activity itself influences the climate locally. When Kilauea releases sulfur dioxide gas, it can react with moisture in the atmosphere to form a hazy volcanic smog known as VOG. This haze drifts across communities, sometimes affecting air quality and agriculture. During major eruptions, ash and steam can temporarily alter visibility and sunlight. And yet, even amid fumes and fresh lava, ecosystems persist. Newly cooled lava appears lifeless at first, black, jagged, still radiating warmth. But within months, wind-blown seeds and hardy pioneer species begin the slow process of colonization. Rainwater pools in cracks. Lichens and mosses cling to stone. Over time, soil forms grain by grain. In this landscape, life does not wait for perfection. It adapts to change. The climate of Kilauea's slopes is not merely a backdrop. It is an active participant in the cycle of destruction and renewal. Rain nourishes what fire has cleared. Wind carries seeds to fresh ground. Sunlight warms newly formed rock. Together, volcano and weather create one of the most dynamic ecological stages on Earth, a place where land is never static and where life continually negotiates with fire. At first glance, a fresh lava field seems utterly lifeless. The surface is black and jagged, still warm beneath the sun. Sharp ridges of lava cut across the ground like frozen waves, while smoother pahueho flows curl and harden into rippled stone. No soil, no shade, no visible movement. And yet, life begins almost immediately. The first arrivals are often microscopic, lichens and bacteria that cling to bare rock. These pioneers slowly break down the basalt, trapping dust and organic particles. Rainwater seeps into cracks. Wind carries seeds from nearby forests. What appears barren becomes a quiet laboratory of renewal. Among the earliest visible plants to take root is the ohi-a-lehua tree. Its twisted trunk and bright red blossoms stand in vivid contrast against dark lava. The ohia is uniquely adapted to volcanic terrain, sending roots deep into fractures where moisture collects. Over time, these trees stabilize the rock and help create the first layers of soil. Ferns follow, unfurling delicate green fronds from narrow crevices. Moss spreads like velvet across hardened flows. Native grasses anchor themselves in ash deposits left behind by eruptions. Slowly, almost invisibly, a forest begins to reclaim what fire erased. Animal life adapts as well. The nen, Hawaii's state bird, walks confidently across rough lava plains, nesting in sheltered areas. Insects colonize young ecosystems rapidly, feeding on new plant growth. Some species have evolved in isolation for thousands of years, uniquely suited to this ever-changing environment. Even near steam vents and sulfurous fissures, hardy organisms survive. Heat-tolerant microbes thrive in extreme conditions, demonstrating that life can endure where it seems impossible. The ocean, too, responds to volcanic change. When lava pours into the sea, it destroys marine life in its immediate path. But over time, the newly formed underwater rock becomes habitat. Coral larvae settle. Fish return. What began as devastation becomes foundation. On the slopes of Kilauea, destruction and regeneration exist side by side. Forests may burn or be buried beneath molten flows, but they return, sometimes within decades. Here, adaptation is not dramatic. It is patient, root by root, leaf by leaf. In this volcanic landscape, life does not resist change. It grows through it. For native Hawaiians, Kilauea is not merely a geological feature. It is sacred, alive, and deeply woven into cultural identity. At the heart of this spiritual connection is Pele, the revered goddess of volcanoes, fire, lightning, and creation. According to Hawaiian tradition, Pele dwells within Halemaʻumaʻu crater at Kilauea's summit. The glow of molten lava is seen as her presence. Eruptions are expressions of her will. Stories passed down through generations describe Pele's journeys across the islands, her fiery temperament, and her transformative power. In chants and oral histories, she shapes the land, battles rivals, and creates new ground from molten rock. These stories are not distant myths. They are living narratives tied directly to the landscape. When lava flows, it is sometimes described as Pele traveling across the land. When the crater glows red at night, it is said that she is awake. Offerings are occasionally left near volcanic vents, flowers, food, or small tokens of respect. Visitors are often advised not to remove lava rocks from the island, as doing so is believed to bring misfortune. Whether taken literally or symbolically, such practices reflect a profound reverence for place. In Hawaiian worldview, the land, Aina, is not property. It is ancestor, provider, and relative. Humans are part of a larger living system that includes mountains, ocean, sky, and fire. Kilauea embodies this relationship between destruction and renewal. Lava may bury forests and homes, yet it also creates new land that future generations will inhabit. Traditional chants, oli, and dances, hula, preserve the memory of eruptions and honor Pele's presence. Cultural practitioners continue to gather near Kilauea, especially during periods of volcanic activity, to chant and offer respect. Science may explain magma movement and tectonic forces, but spirituality provides meaning. This coexistence of scientific understanding and sacred tradition is part of modern Hawaii. Kilauea is studied with satellites and seismographs, yet it remains a place of prayer and ceremony. To stand at the edge of Halemaʻumaʻu crater is to feel both realities at once, the measurable heat rising from magma below and the intangible weight of centuries of belief. Kilauea is more than a volcano. It is a storyteller of fire, a reminder that land is alive. And in Hawaiian tradition, it is not simply observed, it is honored. Long before written records, the eruptions of Kilauea were remembered in chant and story. Native Hawaiian oral traditions describe fiery events that reshaped coastlines and forests, preserving geological history in poetic form. These accounts, passed down through generations, align remarkably with modern scientific understanding of past lava flows. The land itself, layered in basalt and ash, serves as a physical archive of these ancient eruptions. In the early 19th century, Western explorers and missionaries documented Kilauea's dramatic lava lakes within Halemaʻumaʻu crater. Observers described a churning, incandescent surface, sometimes rising, sometimes draining, like a living furnace within the earth. These early accounts drew global attention to the volcano, establishing it as one of the most accessible and continuously active volcanic systems in the world. By 1912, formal scientific study took root with the establishment of the Hawaiian Volcano Observatory, perched near the summit. It became one of the first permanent volcano research institutions on Earth. Seismographs were installed to detect earthquakes, Tilt meters measured subtle swelling and sinking of the ground. Gas sensors tracked sulfur dioxide emissions. For the first time, Kilauea's inner workings were monitored systematically. The mid-20th century brought some of the volcano's most spectacular displays. In 1959, the eruption at Kilauea produced towering lava fountains that shot hundreds of meters into the air, illuminating the night sky in brilliant orange arcs. Molten rock rained back into the crater, forming a vast lava lake that later solidified into cracked, steaming crust. In 1983, a new chapter began along the East Rift Zone. What started as a fissure eruption evolved into one of the longest-lasting volcanic events in recorded history. For decades, lava flowed almost continuously, building cinder cones, burying roads, and extending the coastline as molten rock poured into the sea. Entire communities were displaced. The landscape transformed again and again. Then came 2018, a year that demonstrated both the predictability and unpredictability of Kilauea. A sequence of earthquakes signaled magma movement beneath residential areas. Fissures tore open streets in the lower Puna district. Lava fountains erupted in neighborhoods, destroying hundreds of homes. Meanwhile, at the summit, the caldera collapsed dramatically as magma drained from beneath it. The crater floor dropped by hundreds of meters in a series of explosive events, reshaping Halemaʻumaʻu itself. Each eruption adds to a growing body of scientific knowledge. Researchers study lava chemistry to understand magma sources. Satellite imagery tracks ground deformation. Drones capture thermal data from above active vents. Kilauea has become a global classroom for volcanology, a place where theories are tested against real-time geological processes. Yet despite decades of observation, the volcano retains its mystery. Magma pathways shift unexpectedly. Eruption timelines change. Instruments provide warnings, but never certainty. Kilauea teaches scientists humility. It reveals the dynamic nature of our planet, not as a static sphere, but as a system constantly in motion, constantly reshaping its surface. Today, much of Kilauea lies within Hawaii Volcanoes National Park, where visitors can safely witness the raw processes that built the island. Tourists walk along crater rims, peer into steaming vents, and traverse hardened lava fields that were molten only years before. At night, when conditions allow, the glow of lava reflects off low clouds, an otherworldly spectacle that draws observers from across the globe. Interpretive centers provide geological context, blending science with cultural history to deepen understanding. Yet access comes with caution. The volcano is monitored continuously by scientists from the Hawaiian Volcano Observatory and the United States Geological Survey. Networks of seismometers detect earthquakes. GPS instruments measure ground movement to the millimeter. Gas sensors track emissions that may signal rising magma. Public alerts and hazard maps are updated as activity changes. This partnership between science and public engagement defines modern Kilauea. It is a destination of wonder, but also a landscape of risk. Visitors stand at safe distances, gazing into a crater that may erupt again tomorrow. And through careful monitoring, the living pulse of the volcano is watched, respected, studied, and never taken lightly. Life beside Kilauea means living with uncertainty. Future eruptions are not a possibility, they are inevitable. Lava may again flow into residential districts. Volcanic gases, especially sulfur dioxide, can degrade air quality and threaten agriculture and public health. Coastal ecosystems face sudden transformation when molten rock enters the sea. Infrastructure, roads, power lines, water systems must constantly adapt to shifting ground. Climate change adds another layer of complexity, as heavier rainfall may destabilize fresh lava slopes and increase erosion. Even with advanced monitoring, exact eruption timing remains uncertain. On this island, preparedness is survival, and change is constant. In the glow of Kilauea's crater, we witness the Earth becoming. Mountains rise from molten depths. Coastlines expand into open ocean. Forests fall, and forests return. Beneath every step lies stone that was once liquid fire. Kilauea reminds us that the ground beneath us is not fixed. It is alive, shifting, breathing in rhythms far older than humanity. Its eruptions inspire awe, humility, and reflection. Here, at the meeting of fire and sea, we are reminded of our place in a changing world. The planet is still creating itself, and we are only passing through.